can I have a machine which can run fourth code truthfully? Okay, thank you very much.
Thank you, Dr. Ting.
Kevin, back to you.
So, Sam, you're up. Introduce yourself and on with the show.
Okay, so my name is Sam Falvo. I have started numerous Forth-related and homebrew computing-related projects over the years. Let me do that, and let me start a little bit with, why is this not working? Here we go. Let's see here. Is my screen visible?
Yes. Your screen is visible this time.
Excellent. I apologize in advance for my laptop. So back in 2004, I started a homemade computer. I don't know why. Hang on. This window is like occupying my screen, and I don't know why I can't move it. Let's try this again. Nope, still there. Okay, well, I'm just going to have this big black rectangles occupying a portion of my screen, unfortunately. I don't know. I don't think you guys will see it, but I know I do. So what you see behind me here is a set of circuit schematics for my very first homebrew computer design. It was built in 2004, and it ran at 4 megahertz. And it basically was just a proof of concept. I mean, you can take a look at the schematic, and you can see we have over in this the upper left-hand corner here, we've got the processor, the 65816 CPU. This is the same CPU that powered the Apple II GS, as well as the Super Nintendo system. In the middle here, we've got RAM. This provided it with 32K of RAM. And on the far right-hand side, we have the one and only I/O chip, which does not have anything connected to it because all I did was basically power LEDs from it. And then we have down at the lower left-hand side, we've got our 174 logic chip that did all the address decoding. And that was basically it. So we have RAM and we've got I/O, but you'll notice that there's no ROM. So how did this thing bootstrap? And the way I did it was I mapped RAM to the upper 32K instead of the lower 32K like you normally do with these chips. And I was able to do that because the 65816, unlike its 6502 predecessor, allows me to relocate both the stack and the zero page, which is now called direct page, anywhere in the first 64K of memory. So all I needed to do was find a way to load software into RAM and then release the CPU reset, and then the code that I loaded in would be responsible for relocating direct and stack pages accordingly. And the circuit that I came up with to do that was driven by a PC parallel port, which you can see the rough connection here, and a whole bunch of 74595 chips, which converted serial bit stream to parallel bytes and allowed me to basically use this as a crude DMA engine. So this was back in 2004, and I never really got a whole lot further than that with this. I wanted to. In fact, the original design for the Kestrel 2, before I switched over to using FPGAs and dedicated fourth engines, was basically a variation of the circuit that included way more than I could accomplish with my technical skills at the time. It was to have like graphics. It was supposed to have, you know, some kind of sound capability, and of course PS2 powered keyboard interface and mouse interface, and so on and so forth. All the bells and whistles that you would come to expect from a computer approximately equal in power to an Apple II GS. Over the years, I started the Kestrel 2, or restarted the Kestrel 2 using a different processor architecture. After I designed my circuitry to run on an FPGA, I realized I don't need the 65816 anymore. You know, I could do all this stuff just straight inside the FPGA. The FPGA was of course big enough to do that, and that eventually led to the Kestrel 2 computer, and then from there the Kestrel 2 DX, and then from there I eventually wanted to start the Kestrel 3, which, unlike the 2 and the 2DX, I never actually completed. So over the years, I've created a whole bunch of dead projects, in a sense. Basically, things that started, things that I thought that I could accomplish in a reasonable time frame, and just never was able to complete them due to either life just getting in the way, or you know, you work on it so much that you get burned out, and so you just kind of put it on the back burner. You intend on going back and finishing it, but again, you just never do, right? So there was one SVFIG meeting that I gave a presentation on, and I got one particular bit of feedback in the YouTube comments that was like, you know, you've started all this wonderful stuff, but you know, you never actually finish anything. You know, why don't you finish something? And you know, it was, he's not wrong. And so what I'd like to do is, I would like to finish, if you will, the Kestrel 1, which was this particular circuit here that you see here. This proof of concept was a great experience. I enjoyed working with this processor. I love this processor, in fact, probably irrationally so. And so I would like to basically flesh out this design, and I realized, you know, 2004 is essentially just around the corner. So it would be kind of neat to finally work this design into something workable and have it done by the year 2024. It would be like the 20th anniversary of the Kestrel 1. So that's kind of what I'm doing with my spare time at the moment, is trying to build a system that is an extension of what you see here. And that leads me into the emulator that I'm currently working with. So let me close that out. No longer need you. So I have an emulator that I've written. Actually, basically, I wrote a library some time ago called lib65816, which is an extraction of the CPU module from an old Apple II GS emulator, which then ended up inside Alan Cox's D65C816 project. And then I kind of inherited that project and turned it into my Kestrel 1, or a desirable version of the Kestrel 1 20th anniversary emulator. So I'm kind of using this software as my development platform. And it doesn't do a whole lot at the immediate moment. As you can see, it basically, you can mount unrealistic disks. I say that because the interface to it is super, super simple, unrealistically so. But it's enough to get the emulator working and do some software development with it. And it's got Unix console I/O capability, and that's essentially really all that it does. So let me try running that here. So if I go to if I come into there, if I type in K1 menu, for example, you'll notice that it kind of, that out of the way, it boots up. Basically, it attempts to load 32 kilobytes, roughly, basically around 31 actually, from the virtual disk, and then it drops into what will eventually be a machine language debugger. As you can see, it doesn't really do anything now. It doesn't respond to any key presses, but it does do a register dump. And that's as far as I've gotten to date. But what you see here is the complete set of registers. You have the E bit, which determines whether or not it is working in 6502 or 65816 mode. You see the program counter, which is a 24-bit register. Well, that's a bit of a convenient lie. It's actually two registers. You have the program bank register, which is the K register. That's that one there. And then the program counter proper, which is still a 16-bit register. We have the data bank register, which between these two bank registers, that allows you to place code and data anywhere in 16 megabytes of space. And your usual 6502 registers. You have the accumulator and the X and Y index registers, and you'll notice that they are 16 bits wide rather than 8 bits wide. The stack pointer is now proper 16-bit register as well. And the direct page register, which is what you use to relocate the 0 page anywhere in the first 64K. And you'll notice that there are two new flags in the flags register. The M and X bits, that determines how wide of an operand you're working with when you do additions, comparisons, loads and stores, that sort of thing. M is for the accumulator and X is for the two index register. So that's kind of the state that describes a 65816 program. And right now the emulator basically just does what you see here. The emulator does actually have a virtual frame buffer implementation as well, which is kind of where what this window is. I just don't use it at the moment because I'm still developing the foundation software. Let's go back here. So the idea here is to work on getting the system software running. And the system software that I've always wanted to run has been just like the Jupiter Ace. I would like it to boot into Forth on power on. So my goal is, once I get a reasonable enough monitor to be able to poke about in memory, to actually start writing a subroutine threaded Forth environment for this platform. That Forth environment, I have not started yet, but the idea was I wanted to write it as close in Forth as possible. And so that's where this project comes in. Project Shoehorn. This is a very simple compiler. And what it does is, let's see here, I need to go into tree, and there we go. So this is what the input currently more or less looks like. I will zoom that in for people. And you'll notice that I'll start out, looking at the code down here. It looks kind of like a typical Forth cross compiler or Forth target compiler, right? So basically, You have your normal colon definitions. You have your begin, agains. I also support until, repeat, while as well. I just haven't put them in here. If, else, and then, of course. We have the ability to compile strings. So it looks and feels very similar to a more traditional Forth environment. You'll notice, though, that there are some strange things, like this TX colon, right? So you'll notice that I'm giving this two names. I've got one name, which is a symbol that you would assign, say, if I were to call this from C, for example. And then there's the fourth name. Now, in code, obviously I use the fourth name. So what I'm actually doing here is I'm actually saying, here's the fourth definition that I'm defining. But since I'm not generating binary code directly into memory, what I'm doing is I'm actually generating assembly language code. So I need symbols that will work with the assembler that I'm using. So that's kind of what these are doing up here. So the XREF basically is saying these words exist. Trust me on this. They're just not in this source file, right? It's kind of like the extern keyword, if you're familiar with C programming. So basically saying extern, drop, dupe, over, and so on and so forth. This word is typically used because it's more compact. But the caveat is the fourth word and the assembler symbol have to align with each other. In the case that it doesn't, though, we have this X name, and this does the same basic thing. It basically says, I'm assuming that there's an external definition, named CFetch, for example, and its equivalent fourth name is CFetch. So basically, I'm creating a mapping of Forth symbols to the equivalent assembly language symbols. And what that would allow us to do is to generate assembly language output given the input that was there. So if I do Forth shoehorn, oops. If I do that, actually, right? So if you take a look, for example, it's generating 65816 assembly language code for a particular assembler that I'm targeting. And inline strings, for example, expand to these assembly language sequences here, where it compiles a jump subroutine to a handler, and then I compile the string directly in line with the code. If I do, let's see here. So here's an example where I use 1 minus and 1 plus, for example. That line there, you'll notice that it uses the assembly friendly name for the definition. Now these definitions don't actually exist in this particular source listing. It's expected that I would provide them outside of the source listing. So the goal here is to make a bootable Forth image using this cross compiler, targeting this emulator. And the thought process behind it is, if I can get it working on this emulator using its most basic of I/O environments, porting it to the hardware would be much simpler than if I were to do this talking directly to the hardware to begin with, because it allows me to debug the Forth environment before I even could care about the user interface hardware. Whether I'm talking to a UART, for example, or if I'm drawing pixels on a screen, I don't have to worry about that just yet. So this is kind of where I'm going with. And you'll notice it is subroutine threaded. As I said, there are a few inline functions. For example, increment X and then load accumulator. This is just how I implement zero branch, basically. I want to lay out the stack in such a way that the load accumulator happens after the stack pointer manipulation, so that way there I can just test the flags directly. So that's kind of an implementation detail that's probably worth another talk at another time. But yeah, for the most part, it's all jump subroutines. And the idea is that each of these is either another colon definition, such as entry type here, or a primitive that you supply externally to the program. So that is a quick demo of Shoehorn. The actual program structure itself, you'll notice that I've broken it up to a bunch of different files here. And the top level file is the compiler.fs, and you'll notice that it's basically just a map of what needs to be implemented and when and where. Most of the code is actually processor independent. You'll notice that I have this file that is just for 65816, and all of these emit functions down here. These are the interface to the rest of the compiler. That as long as you can conform with this interface, you should be able to port this fairly easily to any other processor that you like, which is part of the my rationale for this. Like, I want to be able to work on this fourth environment for this particular processor, but as people who know, as people who follow my projects know, I'm also interested in RISC-V as well. So I don't want to find myself in a situation where I have to basically rewrite everything from scratch just to target the RISC-V. So I wanted to pay particular attention this time around, hindsight being 2020, I guess, so that I have this interface, which will allow me to retarget this compiler much more simply than, say, retargeting a C compiler or anything like that. I mean, this is 1, 2, 3, 4, here's 8, just shy of 12 functions that I need to change to retarget this compiler. So that's kind of the status update of what I'm trying to do. The new, also about the name change, which I hadn't mentioned yet. So going back to the history of the Kestrel project, Raptor Engineering is a company that also produces open source hardware, computing and stuff. They've got a lot more resources than I do. Well, they came out with a small single board computer for, I can't remember what function it served, but they called it the Kestrel. And so when that happened, I decided at that time to retire the Kestrel name for my series of projects. And that involved me going through a little bit of a painful stretch there, but yeah, so I'm basically back at it. But this time, instead of calling it Kestrel, I'm calling it ForthBox, because the idea was this machine will boot into Forth. So yeah, the ForthBox is going to be the new name for the Kestrel 1, the completed Kestrel 1. And so that's where I'm at right now. So I've got a target compiler, which I believe works. I haven't tested this in actual code yet. My plan is to do that within the next month or so. I've got an emulator that is working well enough that I believe will run a machine language monitor. I want to get the monitor working so that I can test this. So hopefully within the next month or two, I'll be able to put all the pieces together and have a working system. And then once I've got the target compiler kind of debugged, after that, I plan on actually starting to implement an actual Forth environment. I'll probably use eForth as a basis, but I'm not beholden to ANSI Forth or anything like that, so I may diverge from standards. just to get something working. I'd rather have something working than to have a standards compliant thing that takes months upon months to get working. So yeah, it is coming together. It is also taking a lot longer than I would like, but that's also because, you know, I've got a day job like everybody else, right? And it's a very technically challenging day job, and I enjoy spending time doing that as much as I enjoy time doing this. So so that's kind of where I'm at, and I guess I took a lot less time than I thought I would. So I guess I can entertain some questions. Oh, I see I got 2 messages in chat. Check. Yes, poor man's SPI. Yes, actually, the circuit itself was kind of inspired by IBM's IPL, initial program load equipment. So when I first built it, I called it the IPL circuit. But yeah, essentially, it's a little bit more complicated than SPI, but it could do, SPI does probably about 80 to 90% of it. Let's hear the next comment. Have you considered using dual ported memory with one port hooked to the microcontroller running forth and to inspect the memory? I have not, actually. That's actually a good idea. I will consider that for future projects, especially with the RISC-V, because RISC-V is a lot more difficult to get up and running than the 65816. Let's hear, the NMI could be used to dump and restore CPU state tuned from well-known addresses. Yep, and such setup should allow debugging with minimal overhead. Yeah, that's actually a good idea. I had not thought of that. Thank you for that suggestion.
Sam, was it true that at one time you actually were selling Kestrel kits?
So that was an intention, but I'd never actually gotten that far. Back a couple of years ago when I was unemployed, I was trying very hard to try to get the Kestrel into a sellable state, but I never got that far. I ended up landing a job before I got far enough to do that.
I know what you mean. I'm always pleased that the folks that present beg off because they have lives and jobs and are succeeding at them, and it's a mixed blessing, at least for the program chairman trying to find a speaker or two to fill our meetings. Speaking of which, as we're winding down, let's get Sam to wrap it up. If there are any more questions.
I do want to point out that I do intend on getting the ForthBox to a sellable state at some point. I just don't know if I actually will sell it, because getting something and productizing it is actually the easy part of the whole thing. The hard part is the follow-up to that, which is actually being the sales channel. So my goal is to have everything in open source, accessible. It should have documentation written for it and accessible in the repository. And I will include a link to the repository. I will send that out to David. So there's that. But in terms of actually selling a kit under a doing business as entity, I don't know if I'll have the time to be able to do that. It's a very time-consuming activity, but I do intend on getting it to a point where if I were to find myself unemployed again, I want to be able to ramp up on that particular project and revenue stream as quickly as possible. So yeah, so the idea is to get it to that point, and it'll probably end up there and just kind of languish until necessary.
when you reach that point, I encourage you to reach out to folks like Nash, who has participation in the business that puts forth things together or other things together and sells them on eBay in batches. There are examples of entrepreneurs in fourth space. The Dazzler comes to mind. How many bought a Dazzler? Okay, so if you want to hook your Arduino-esque interface to HDMI, that's the way to go, in my feeble-minded, humble opinion.
Or hack together some firmware for a Raspberry Pico to outbid Bing DVI.
Seems excessive.
It's a €4 part, so.
Yeah, I understand what you're saying, but I think if I wanted to be building something or making something that was compatible with pretty much everybody's monitor and everybody's TV and everybody's implementation of HDMI, at least the ones that meet the standard, I'd probably want to go with a Dazzler. The development process for that device was described in Bowman's newsletter, and I guess he bought on eBay HDMI stream grabber analyzer, which evaluates your correctness or lack thereof. And he said good success with being compatible with everything.
That will be something I look into, I guess, when the time is right.
Yeah, well, the thing that I've always felt is that, if I was going to do something like that, I'd probably want it to the folks that have actually done it. And Nash has certainly spoken about the trials and tribulations thereof. And I've been occasionally dunning him and Bowman to speak to us on those sorts of issues. Mostly what I say is, speak about anything you want, but, want to talk about this would be great. I want to thank the speakers that speak, and especially the ones before us now. Thank you, Sam. I'd like to have a short discussion after Bob Armstrong is done. Bob, are you on deck, by the way? Because you're up.
Yeah, you can hear me. And,
I can hear you. Hang on just a second. I did want to blather for just 1 minute more before I hand it over to you. The thing I'd like to do is talk about maybe going around the room and in folk singing at a con, you go around the room and you either suggest a song or perform a song